Hi guys, today we will study about polymers. In polymers, we have the topic as polydispersity. Polydispersity and molecular weight distribution in polymers. A polymer is made up of large number of monomeric units and polymeric samples contain molecules of different chain lengths. So, polymer having different size, weight leads to heterogeneity in sample which is known as polydispersity index. So, in monodispersity samples, all chains are identical chemically as well as in size. The polydispersity correlates with the average molecular weight concept but not with the dispersity pattern of a polymeric sample. We can take an example. 40,000 is the average molecular weight of a polymer sample, means the value of molecular weight of a molecule ranging between 20,000 to 80,000 or from 500 to 1000, and this figure is known as example. Therefore, two polymer samples of same 40,000 average molecular weight have similar properties in one respect and different in other respect. Hence, it is necessary to have the idea about both the average molecular weight and the dispersion pattern of a given polymeric sample. The dispersity can be expressed by a simple molecular weight distribution curve with respect to a lowest to the highest molecular weight. You can observe the graph in a slide which shows the average molecular weight, number average molecular weight, and different types. The given curve also shows the partial molecular masses. The curve shows the respective position of a various average molecular weights in a polydispersity polymer sample. That is, molecular weight is greater. Polydispersity gives an idea about the lowest and highest molecular weight species and distribution pattern of the molecular weight species. Polymers prepared by different polymers technique shows different polydispersities. It occurs due to the variation in the degree of polymerization attained by different molecular during the process of polymerization. The molecular mass distribution of two samples having the same number average molecular weight but different polydispersities. This sample has narrow dispersion pattern, hence low polydispersity than the sample 2. As the molecular weight distribution becomes broader, dispersity increases and molecular weight and number average molecular weight also increases. You can observe it in the given graph. And for the exceptional case we have for synthetic polymers, mw bar divided by mn bar is higher than 1, as you can observe in the slide. Polydispersity index for different polymers method technique. These are the points given below are important. I want you people to please take down them in the notes and study them. Next, we will move on to the reaction of polymers. Now before we have studied about polydispersity index, now we will see the reaction of polymers given. In this first one we have functional group reactions. These reactions of polymers are divided into 5 general categories. First point, reaction that involved in introduction or modification of functional groups. Reactions that introduce cyclic chains into the polymer backbone. Reactions leading to block and graft polymers. Cross-linking reactions, degradation reactions. However, the polymers in principle undergo all the reactions common to low molecular weight compounds. Contrasting behavior may arise from the polymer's molecular size, shape, and monography. Conformations and localized steric effect might well influence the rate or extent of reaction in different parts of the same molecules. The proximity of the functional group might enhance the reaction by the neighboring group effect. Sometimes the reaction itself might change the physical form of the polymers. In this, let us see the first one, that is introduction of new functional groups. The chlorination or chlorosulfonation of ethylene gives some improved properties. Here is a reaction given below. I want you to please take down and look at it. Next, definition glass transition temperature. The temperature at which the polymers undergo transition from glassy to rubbery state is called as glass transition temperature. Condition: it should be below the glass transition temperature and above glass transition temperature. Below it will be like glass, and if it is above, then it will convert into rubber. Fluorination of polyethylene is carried out by direct reaction between solid polymer and fluorine. When double bonds or benzene rings are present in polymer, post substitution and addition occurs on fluorination. Example we can consider as polystyrene on fluorination gives chemical inertness and solvent barrier properties to plastic bottles. Here is the equation given below. Please observe it. Next point, aromatic substitution reactions such as nitration or sulfonation, chlorosulfonation, etc. occur in polystyrene. The functionalized polymers cross-linked by including small amount of divinyl benzene during polymerization. Introduction of keto groups through oxime to form polyethylene photodegradable thing, that is chemically degradable by action of light, is known as photodegradable. Conversion of functional group. Conversion of one functional group into another is primarily to obtain polymer, difficult or impossible to pre by direct polymerization. Example, synthesis of polyvinyl alcohol by hydroxyl or alcohol by polyvinyl cannot be made directly as vinyl alcohol is unable to form enol form of acetanilide. Synthesis of other polymers difficult to obtain directly by saponification method. And second one is Hoffman degradation of polymeride. The equations are given below. You can just observe the equation, and I hope you are taking down the equations in the slide. Next is reaction of polymer with different functional group. A polymer with a different functional group differ in their chemical properties. We study the different polymers with different functional group and obtained different products whose properties will be different from earlier chosen polymers. The oxidation of polymer will help us to modify thermally, mechanically and solubility, etc. Next is hydroxy-functional group. Vinyl polymers are the group of polymers which are produced from vinyl monomers. Polyvinyl alcohol reacts with metallic sodium and product obtained after reacting with alkyl halide produces polyvinyl ethers. Polyvinyl also reacts with ethoxide under alkaline condition to yield ethoxy derivatives of PVA. The reaction is given below, and the third condition will be polyvinyl alcohol undergoes alterification reaction. Polyvinyl alcohol can react with acetic anhydride and anhydrous sodium acetate to give polyvinyl acetate. The reaction is given below. And the fourth one is polyvinyl alcohol can also react with isocyanide to form the derivatives of urethane Mg, that is magnesium. The hydroxy group of polyvinyl alcohol reacts with isocyanates to form polyvinyl cyanides. The reaction is given below. And next one is aldehydic functional group. The simplest form of aldehyde in case of organic polymer is polyacrylero. It reacts with sodium bisulfate in a similar manner to that of aldehydes and reacts in the formation of sodium salts of polyacrylorine. The product formed in water soluble whereas polyacrylene in water insoluble polymers. The reaction is given below. Similarly, polyacrylorine react with hydroxylamine and polyhydroxene and forms respective hydroxine products. The reaction is given below. Please take down all the reactions in this slide and observe. Acetates are formed by treating polyacrylene with alcohol. And coming to the last one, that is carboxylic acid functional group. The simplest form of COOH group of polymer is polyacrylorine acid. This consists of a large number of COOH group and the properties are similar to the normal carboxylic acid. When polyacrylorine acid reacts with alkaline solution of sodium hydroxide, the sodium salts of polyacrylorine acid is formed. The sodium salt of polyacrylorine acid undergoes isomerization inside the solution. When the large number of molecules undergoes association, the product formed is called polyelectrolyte, which are good in conduction of heat and electricity. Carboxylic acid can also react with ethoxy group to form the esters, or association will lead to the formation of polyesters. Here are the two reactions given. Please observe it. In contact with carboxylic acid functional group. Next is other functional group reaction with procedure. The amino group present in polyvinylamine can react with the anhydride and it can also react with benzene sulfonyl chloride to form the sulfonyl substituted polymer. Sulfonyl substituted polymer is formed in the below reaction. The nitro group present in a polymer can be converted to amine group by reduction with hydrogen. Hence, polynitropropylene can be converted to polypropylene amine by reduction. When polynitropropylene undergoes reaction with hydrogen gas, it forms polypropylene amine. The amino group present in a polymer chain is similar acid amines can be undergo Hofmann's degradation reaction to yield amine group. That is, polyacrylorine amide undergoes Hofmann degradation reaction in presence of 2 times of bromine, that is Br2 and OH minus to form polyvinylamine. There is a reaction in which polyvinylamine is formed. Next, many polymers contains aromatic ring can undergo reaction characteristics to the benzene ring or aromatic nucleophiles. The benzene nucleus of polystyrene can undergo sulfonation reaction to form and it can be nitrated in presence of nitrating mixture to give polynitrostyrene. Polystyrene can undergo Friedel-Crafts reaction to form a unique polymer called polyvinyl cyclohexanyl benzene. The reaction is given below. A polymer called polyfluoropolystyrene is synthesized by the fluorination of polystyrene during this reaction. The hydrogen fluoride gets eliminated as byproducts. The reaction is given below. You can just observe how the polyfluoropolystyrene is formed by reaction with F2. Next is ring forming reactions. Ring forming reactions are the one of the most important things which are asked in the exams again and again. Please concentrate on this. The introduction of cyclic units in a polymer results in greater rigidity, higher glass transition temperature, and high thermal stability. The important cyclization reaction is synthesized of carbon fibers. The carbon fibers is made by controlled pyrolysis of polyacrylonitrile fibers. This reaction is complex in nature, involving free radical process, consists of many reactions leading to highly cross-linked graphite-like polymer accomplished by loss of HCN and N2 and quinine type structure are formed in presence of oxygen. If graphitization is applied to fibers under stress, longitudinal order results and the graphite fibers exhibit very large modules. Carbon nanotubes and nanometers wide seamless concentric graphite tubes are formed at 4000 Kelvin in carbon furnace. The nanotubes are much stronger than conventional graphite fibers. There is a reaction where you can see the thermal condition under the heat. There is a formation of new polymer, and this leads to the two different products, that is one will be quinine and other will be ladder graphite type polymer is formed. The ladder structure are formed from only polymethyl vinyl ketone by intramolecular aldol condensation. These structures are formed due to the dechlorination of PVC, that is polyvinyl chloride. There is a reaction which you can observe. Next is block and graft copolymer formation. The polymer containing functional end groups are usually having tendency of forming block polymers. Example, styrene polymerized with H2O2 or FeSO4 redox system forms hydroxyl terminated polymer yield polystyrene. Subsequently, read with an isocyanate terminated polymer yield an AB block copolymer through urethane linkage. Polymer containing relative functional group are called living and may be converted into block copolymers. Peroxide groups are introduced into polymer chain and can be used to initiate new chain. In presence of small amount of oxygen, peroxide units can be formed. In a polymer back by polymerizing a monomer, the reaction is given. Another method to obtain chain end radicals is by mechanical degradation of homopolymers using ultrasonic radiations or high speed stirring is another method for obtaining the block and copolymers. Next is graft copolymers. There are three general methods of preparation of graft copolymers. First one is monomer is polymerized in the presence of polymer with branching resulting to form chain transfer agents. Next is a monomers polymerized in the presence of polymer having relative functional group or position that are capable of being activated. Next is two polymers having reactive functional groups are correlated. Next is three main components are required for grafting by chain transfer polymers, monomers and initiators. The initiators performs two roles. First one is it polymerizes the molecule, that is monomer, to form a polymeric radical or ion or complex, which in turn reacts with original polymers. Next is it reacts with the polymer to form a reactive sites on the backbone and then polymerizes the monomers. It is necessary to consider reactive ratios of monomers so that grafting is ensured and the frequency of transfer to determine the number of grafts. The mixture of homopolymers results along with the graft polymers. Grafting usually occurs at sites which are prone to undergo transfer reactions, such as it contain carbons adjacent to double bonds in polydienes or carbon actions adjacent to carbonyl groups. And next one is cross linking. Involves in covalent bonding between macromolecules of single polymers. Cross-linking is the most important reaction of vinyl polymers and is fundamental to the rubber and elastomers industry. It can be brought about by vulcanization using peroxides, sulfurs or sulfur-containing compounds. Free radical reaction caused by ionizing radiations. Pyrolysis involving photosensitive functional groups. Next is chemical reactions of labeled functional groups. And last one is Coulombic interaction of ionic species, that is cross-linking is formed. Formation of bonds between different chains of linear polymers leading to three-dimensional network structure. Cross-linking may be due to secondary bonds, and chemically cross-linking involves covalent bonds, which is irreversible. A chemically cross-linked polymer becomes a thermostat. Next one is peroxide initiator cross-linking. This is the last one, and this is also the most important one, which is asked in the examination many times. Peroxide cross-linking of saturated polymers such as polyethylene occur by hydrogen substitution by radiation, resulting in formation of homolytic cleavage of peroxide followed by radical combination with unsaturated polymers. Hydrogen substitution occur at the allylic position with the subsequent cross-linking resulting in formation of radical combination. There are the two equations which you can observe about peroxide initiation cross-linking. So this was all about the different types of cross-linking and the functional groups attached to the polymeric ring.